procedure of the pre-acceleration and acceleration of the particles. So you have seen here this machine producing the protons. The small orange linear accelerator, LINAC 2, you have seen it as well. And then the protons are sent in a small simple accelerator called booster. Inside this booster, these separate bunches of protons will be shaped as they are necessary for the new accelerator LHC. 4 centimeters long, each bunch, 7 meters distance. This is done exactly here. Then the beam is sent to the oldest accelerator TS from the 1959, which is in front of you, only 630 meters in circumference. What is inside, you could see on this big photo on the wall. The acceleration will continue here up to the highest possible energies. Then the beam is sent to a second accelerator of the same kind, but much bigger, already 7 kilometers, called super proton cyclotron. The acceleration is continuing. Finally, the protons are injected into the new big accelerator LHC. But the new accelerator has 2 separate beams accelerate in opposite direction. The old accelerators, they have only one beam. That's why we must fill up the new accelerator first in one direction, and to fill up the 27 kilometers, this is taking 17.5 minutes, and then the same must be done for the opposite direction, again 17.5 minutes, 35 minutes, and then the acceleration in the new accelerator is continuing for 20-25 minutes. So after about 1 hour, we may have beams with energy high enough to start the collisions. To produce collisions, we must deviate 2 bunches by 2 bunches on 4 points on the ring of 27 kilometers. They are called interaction points. Around these interaction points are the detectors, and we'll visit with you now one of these detectors at us. So we must deviate with magnetic fields each 2 bunches to make them meet, to make them collide, to start this way producing interactions. Each collision between 2 bunches will produce only about 20 interactions, because the protons are extremely small. Only 20 protons from one bunch will meet by chance, statistically, 20 protons from the opposite bunch, will produce interactions, will create new particles. All the other protons inside the 2 bunches will miss each other, and the 2 bunches will pass one into another this way. And they will continue to run inside the accelerator. And we are using them to produce interactions for a very long time. 15 hours, 20, 25 sometimes, because at the beginning we must inject inside each bunch at least 100 billion protons. The acceleration is starting with 100 billion protons per bunch. Moreover, we may have one bunch every 7 hours, every 7 meters. If you divide the 27 kilometers, this is about 2,800 bunches in one direction, 2,800 bunches in the opposite direction. If you take one bunch in one direction, this bunch will run over the 27 kilometers 11,000 times per second, because the speed is very near to the speed of the light. If you take a second bunch in the opposite direction, the same thing, 11,000 times per second, 11,000 revolutions per second, but in the opposite direction. But each 2 bunches will pass through each other in parallel during the acceleration 30 million times per second. And as I said, when the energy is high enough, we must try to deviate them, to make them meet, to make them collide, to produce interactions. Each collision will give about 20 interactions. If you multiply 30 million per second by 20, we may have up to 600 million interactions per second inside each detector. 600 million interactions per second inside each detector. We could not register. The electronics could not do it. Moreover, the physicists are not interested to register all these interactions because most of them will produce particles we already know. We don't need these interactions. Only small number, but really very small number of interactions could give us the results we're looking for now. That's why in each detector there is a special electronic system called trigger to evaluate very rapidly on the basis of very simple criteria each one of these 600 million interactions and to decide which are the interactions interesting for the physicist. Only the data for these interactions are sent to our computing center to be registered. The physicists will analyze them later on. This way we're registering the data only for about 100 interactions per second. So we make f up to 600 million per second, they will die. We are not interested, only 100 of them are registered for further analysis. So this is the way the detectors are working with the accelerator. So that's it very rapidly. Take a look.